Hello everyone. We can describe and quantify a linear relationship between two quantitative variables using correlation and regression. These two measurements are commonly used, but also often misinterpreted. These are the aim of the lecture. What is the similarity between correlation and regression? The correlation coefficient and the regression coefficient indicate the same strength and direction of the linear relationship. When should we use a correlation and when should we use a regression to quantify a linear relationship between two quantitative variables? Correlation when we only want to know the relationship and not try to predict one variable from the other. Regression when we want to use explanatory variable x to model the response variable y. Here are some common mistakes in interpreting regression and correlation. When two variables x and y have a positive linear association, it does not mean x causes y. It merely means when x increases, y also increases. Let's see some examples. The number of people who drown by falling into a swimming pool increases as the number of films Nicolas Cage increases. Does this mean Nicolas Cage film caused people to drown in the swimming pool? No, this positive correlation happens by coincidence, so it does not mean Nicolas Cage film caused people to drown. This graph shows the relationship between the global average temperature and the number of pirates. It shows that the global average temperature increases as the number of pirates decreases. Based on this graph, a headline says, "True fact, the lack of pirates is causing global warming." So, do you think the headline is correct? No, the negative correlation between the number of pirates and the global average temperature is a spurious relationship. These two examples show obvious spurious relationship. Some spurious relationship might not easy to spot. For example, a claim that a certain type of diet causes weight loss. This claim is made based on a correlation. Does the diet cause the weight loss? Or the loss are due to other factors? People who are on diets might also adopt a healthier lifestyle, such as increasing their exercise regimes and reducing junk food. Can you be certain that the observed weight loss is due to the diet and not other factors? It's always tempting to use a regression equation to predict the response variable for any value of the explanatory variable. However, extrapolation should be avoided. In this bacterial growth curve, a linear regression equation is generated for the exponential phase, day 4 to 9. Can we use this regression equation to predict the number of cells at 22 days? No, because the relationship between the number of cells and days change from positive during the exponential phase to negative during the decline phase. Depending on the system we work with, extrapolation might not be possible due to the natural limit of the system. Remember the Anscombe quartet? These three factors will cause bias in estimating the strength and direction of a linear relationship between two quantitative variables. Therefore, it is important to always plot the data before running the analysis. Now, can you do this?